today. And with that, I was going to close and hand over things to the next session. But I think, and I hope Regina is okay with this, she's moderating our next session, that I will take about 10 minutes to present what would have been presented in that session by Jim Oehmke right now. So let me stop sharing this one and quickly rush into Jim's presentation. And for those of you that didn't hear earlier, oh, sorry, I didn't. Let's see. As I mentioned to people before we got started, let's see, I hope everybody can see this. Jim looks like a big, strong, healthy guy, but it turned out that he got 2 shots yesterday, and so he's not feeling well today. So I'm going to do, we just found out this morning that he wouldn't be able to make it, and so I'm going to do a quick run through this because it really is a good startup, not only for that session on transformation, but also the project as a whole, and goes into more detail than I was able to do. The background of this is that our project originally was set to mainly measure impacts of policy change, but we've modified it over years to measure impacts of policy systems change on contemporary agricultural transformation, and then all of USAID. And that's also we're told that we needed to flex towards COVID-19 issues. And so what I'm going to talk about from Jim is first this change from conventional to contemporary transformation. Second, policy systems are a binding constraint, and this is the context for Rutgers' work. And so let's see. So the conventional wisdom on transformation was that we needed to reproduce the Green Revolution. The problem was inadequate global, regional, local food supply, Indian famine issues. Were narrowly focused on caloric sufficiency, and binding constraints were biotechnical, and they were to be resolved through research success. We continued for technological improvement to take place that drove the productivity gains. And the conclusion was what Jim calls FDF 1.0, and didn't really emphasize policy that much. Now, agricultural transformation, policy or productivity increases, i.e. Higher stable crop yields and reproducing the Green Revolution. Now what Jim has termed the contemporary transformation has some very key differences. There's multiple objectives, SDGs, COP26, habitat, Moss in this session, Anderson in this session, and Nassim talked to some of these issues in our presentations. Technology policy has shifted, and emphasis on private sector, food processing service, multiple livelihoods, Liverpool, Tassie, and Reardon tomorrow, diets, nutrition, Venkat on diet costs, masters in nutrition, Unsabinama, tomorrow, and then water security. So there are some very important differences. the shift is from agricultural productivity to food systems efficiency. Technical process policy innovations are all important for sustained growth in labor productivity, multi-factor productivity growth, and reemphasize individual outcomes, poverty, food insecurity, water insecurity, vulnerability. Focus on rural women, often hungry, poor, and systematically marginalized in policy, economic, and social systems. I think we know some of this. I'm going to skip this one. Mention multiple multiple objectives. We already mentioned food policy changes and food security tomorrow, political will, and country policy readiness tomorrow. Finally, land policy and prices, food prices, sustainable USAID impacts, and seed policy. So with that, I'm going to stop, I believe. Yes, one final point that I think is an important one. Policy and governance, both are binding constraints and underlying causes for some of these challenges. Policy is endogenous, need policy systems change. And tomorrow we're going to talk about political will and how to make these transformations take place. Okay, with that, I am going to stop and apologize. This is not bad. I have 9:03, so I think that managed to squeeze quite a bit into one session. And from here, I will stop talking. I will let Regina take over, and we will move on to the next session. I guess we may need a moment to catch our breaths, and I will get out of the sharing mode. Okay.
So I have Will Martin as the next moderator, so I'm just bringing him up now.
No, not Will Martin, sorry. It should be Regina Birner. Do you have her?
Yep, I'm bringing her up right now. I'm sorry about that.
No problem.
Good morning. It's my great pleasure to chair the following session. And thanks to Carl, we even have a bit more time for discussion in the session because what Jim was about to say, unfortunately, for those who are joining right now, Jim Oehmke cannot be here. So Carl already presented his introductory slides. So it's a great pleasure and a privilege to be the moderator of this first session on sustainable and inclusive agricultural transformation. My name is Regina Birner, and I'm the chair of social and institutional change in agricultural development at the University of Hohenheim in Stuttgart, Germany. And it has been my great pleasure to actually work with the consortium group on various of these exciting topics. As we have heard from Carl in this introduction, it has been one of the core objectives of the consortium to develop an expanded version of agricultural transformation and of the policy agenda that it implies. And in fact, how to achieve an agricultural transformation and use agriculture as an engine of economic growth, that has been a core theme in the agricultural economics literature for a long time. And I think it's fair to say that some of the most brilliant minds in our profession have dedicated their efforts on this topic. An early example, probably well known to all of us, is a landmark paper by John Mellor and Bruce Johnston on the role of agriculture in economic development, 1961, and the book Agricultural Development and International Perspective by Yujiro Hayami and Vern Rutain, first published in 1971. And as Jim was about to say, and Carl has actually reported, the Green Revolution served as an impressive empirical model of the powerful role of agriculture for economic transformation, perfectly in line with the theory that the agricultural economists have developed on the role of agricultural development. And therefore, conventional wisdom, as Carl has said, focused on reproducing the Green Revolution. Yet in the decades to follow the Asian Green Revolution, it became increasingly clear that other developing countries, most notably those in Africa, were struggling to follow this model. And there was an increasing criticism of the Green Revolution also. And Carl has mentioned that also from an environmental and a social perspective. So there were calls for a double green or an evergreen revolution that was acknowledged by M.S. Swaminathan, for example, from India, one of the fathers of the Green Revolution, but also by other eminent thinkers like Gordon Conway and Uma Lele. And the need to take a broader look at the agricultural transformation was also present in another big effort to look at the topic, and that was the World Bank's World Development Report, Agriculture for Development, published in 2008 under the leadership of Alain Deschamps and Derek Byerly. And yet another effort to take a new look at the agricultural transformation was led by Hans Binswanger, another eminent thinker in the field, unfortunately no longer with us, in IFAD's Rural Development Report 2016, which was also entitled Fostering Inclusive Rural Transformation. So as time has progressed since the Green Revolution, the agricultural transformation agenda has become more complex, and Carl has pointed that out already, as several challenges have become ever more pressing. The nutrition transition, the contested role of technological innovation, and as we all know, the urgent need to respond to climate change. The COP meeting just started, and I think it's very much in everybody's mind. So in recognition of these new challenges and how to define the agricultural transformation in a broader perspective and how to identify the policy agenda that it needs, it was very timely that this consortium brought together another set of great minds to think afresh about the agricultural transformation and develop a new vision for it. And in this session, we are very privileged to learn from members of the consortium how this vision should actually look like, and importantly, what the scientific and research basis of this new vision is. Originally, we had 5 presentations. One we actually have already heard from Jim Oehmke, that Carl kindly presented it. Jim is a senior nutrition and food security advisor for USAID. So unfortunately, we cannot hear him and can't have him in the discussion. Therefore, I would go on to invite our next speaker in the program. So we have 4 speakers now in the session, and the next speaker is actually Carl Prey. And you have already heard Carl, but probably also doesn't need really any introduction. But in my role as chair, it's still my pleasure to introduce Carl. He's a distinguished professor of agriculture, food, and resource economics at the School of Environmental and Biological Science at Rutgers State University of New Jersey. Many of you may know that Carl actually did his PhD in economic history from the University of Pennsylvania, and he's internationally recognized for his unique conceptual and empirical research on the role of agricultural science and technology policy in developing countries, an expert on China and India, but also worked African countries. And he's also one of the leading experts on the role of private versus public sector in funding agricultural research, on the role of biotechnology innovation and the institutional environment of innovation. So Carl, I think, is best placed to talk about this important aspect of agricultural transformation, the role for technological innovation and value chain efficiency in agriculture-led growth. Carl, the floor, or rather the screen, is yours.
Okay, thanks, Regina. Let me get myself going here. And apologies to everyone for, I guess the good thing about this, me talking straight through sort of 3 presentations at one time, is that you're done with me pretty much, and you'll just have to hear me intervening later in various things, but not a longer presentation per se. So what I'm going to talk about is kind of, I don't know how to characterize it exactly, but kind of, I think I've switched the title around a little bit, but it's kind of maybe a little retrograde on this, that the thing that I want to start off with in this session is to remind us that even in a contemporary transformation, agricultural productivity growth still is an essential component, and that development economists and policymakers, in their enthusiasm for resilience and climate change and a number of other specific issues, want to remember that we need to continue to invest in agricultural productivity growth if we're going to have this contemporary transformation. My second major point will be that productivity growth is based on innovations by farmers, by public sector research and extension, and by large private and small private firms. So it's a combination of these. Third, the transformation, as the transformation takes place, the role of the private input firms, ag processing firms, and commercial farmers grows rapidly and plays a much greater role than in supplying and developing innovations than in the past. And finally, policy change can contribute to innovation by agribusiness firms and agricultural productivity growth. And so policy change is an important component of this. So first, agricultural productivity growth is necessary. In the conventional transformation literature, we all know that the productivity growth increases incomes of farmers, allowing them to buy more consumer goods, services, agricultural inputs from the urban sector, building up the urban sector. Productivity also facilitates urbanization through the movement of labor to cities and the supply of low-priced food products for processing export. And finally, productivity growth can save resources per unit of agricultural output, which has important environmental consequences. So if you sort of mash these all together, and it's clear that productivity is an important driver of our expanded concept of transformation. That agriculture transformation is not just agriculture, but it includes the input industries, supply chains, food supply chains. It has to focus on reducing poverty, improving nutrition, access to water, reducing pollution and greenhouse gas and resilience. These things are supported by new technology, supported by agricultural productivity growth, new agricultural productivity, and ultimately technology from other sectors. Sources of productivity growth, I already mentioned public sector research, just to reaffirm that the rates of return and the benefit cost ratios of investing in agriculture research, either in the CGIAR or the national research systems, are extremely high, well beyond what they are in almost any other sector. So this is, this is still a huge source of growth. Public extension systems also have high returns to investment, particularly complementing strong public research programs. Private sector firms develop innovations through research and importation of technology and supply of modern inputs and advice to farmers, and farmers put this new technology to work with their knowledge of their farms and increase food production and incomes, and also put pressure on the public sector and private sector to provide technologies that they really need. Just a note, imports account for a big chunk of the innovations also. And we did the study of innovation some years ago it still stands up maybe even more so today, that imported innovations accounted for at least half of the technology innovations, both in even in firms that already do their own R&D. The point about transformation encouraging growth of private sector is maybe is obvious to some, but it kind of struck me recently again that consumer demand for products and services from agriculture has diversified greatly due to transformation. Greater income per capita led to the vegetables, fruits, flowers, or demand for animal protein, but also more demand for sustainable agriculture of various types, and demand for food quality and food safety. At the same time, transformation has improved the ability of private research to benefit from innovations. Processors growing larger and more important can capture some of the benefits from developing agricultural technology that increases farmers' productivity or product quality and reduces the costs of quality products for processing. And then industrial policy that's targeted not just at agriculture, but at the whole industry in terms of patents, privatizations, encouraging FDI, et cetera, also stimulates private sector. And there are some improvements in technological opportunities. Sorry about that. So I put together this just one empirical example, if you will, of growth in R&D in India, and you see that the big chunk of growth in R&D in this 15-year time period was from high-value commodities such as livestock and inputs into that, the processors and the plantations, the sugar industry and the food beverages plantations, and then environmental services, if you will, the biofertilizers, biopesticides, and biofuels. So this transformation accounts for sort of a natural process of improved or increased private R&D. But in addition to that, there are a series of policy elements that can increase the demand for innovation, that can increase the ability to appropriate parts of the gains from innovation and reduce the cost of innovation to private firms. And then, of course, you have to have the basic infrastructure, law and order, transportation, communication, if you really want to improve the innovation ecosystems for successful private innovation. Just two examples, maybe three, I guess, of how liberalization, privatization of these policies work. The slide that I showed you before showed that total private R&D went from about 24 million in 1984 to 250 million in 15 years later. Much of this was driven by the combination of the transformation that I mentioned, but also by these policies of liberalization, foreign direct investment, and large firms being allowed, patent strengthened. And these are documented in some of the papers that Lata Nagarajan and I have written. There are also very specific studies on looking at private innovations in pro-millet, how that led to productivity as a case study. And then aggregate TFP has accelerated since about 2005 due to R&D and innovations, agribusiness, public policy, public research, and extension and other factors. Finally, there are studies of specific impacts of policies such as patent policies and regulations permitting new technology in. Maize yields can be shown as a partial response to policy reforms. And this is an advertisement for Lata Nagarajan's presentation that's going to come next tomorrow. And then just one final point on another important policy is the regulatory policy, and this has been highlighted by the GMOs. These regulations are essential for the spread of new radical technology. Private companies would not transfer GMO traits to countries that don't have a regulatory system. So the countries that did have regulatory systems in place and allowed these technologies in have had huge dividends, maize and soybean productivity in South Africa, and cotton in India. But the regulations, as we know, also can make GMO approval uncertain, costly, and time-consuming, which reduces R&D, and they can prevent the cultivation of GMOs altogether. One final point related to this that has occurred to me of late are one of the example of GMOs in Africa and elsewhere, I think, is a good example of the challenges of changing policies through research and policy advocacy. There's been 20 years of studies by economists showing the positive economic, health, and environmental impacts of GMOs for smallholders as well as large farmers. And there are technologies, ready to go. And so there's economic evidence that these things are really effective. And then there's been support for policy research, advocacy that was done at IFPRI, ISA, AATF, Cornell, and the amount of success that's come out of those activities of USAID and BMGF and others has been pretty limited, with the BT eggplant in Bangladesh being the star, and now BT cowpeas and BT eggplant. So my final word is that that we have an important role, that we have to remember that public sector research is going to be extremely important, and new technology still has a big role to play in contemporary transformation. It does put more emphasis on the private sector, and with more emphasis on the private sector, it means we have to put more emphasis on the kinds of policies that will allow private sector to play a big role. So these are a couple of papers. This first one is a big overview paper that is, I think, it would be useful to many. And then this is one that we've done more recently on how the poor can benefit. So with that, I put an end to my long-winded presentation, and thanks, everybody.
Well, thank you so much, Carl, for this very interesting presentation on important aspects of the agricultural transformation. And I would like to invite all the participants who join us in the webinar to ask questions in the Q&A session. Unfortunately, we don't have the possibility for you to turn on your camera, which would also be nice, but there is the opportunity to ask in the Q&A your questions. Our idea is that we first do hear all 4 presentations, and then we start into the discussion, and then we will pick up the questions you have actually placed in the Q&A session. And with that, it's my pleasure to introduce our second speaker in this session. And our second speaker is Chuck, or Charles Moss. He's a professor. You can already see him. Welcome, Chuck. He's a professor of agricultural finance and policy, applied econometrics and computational economics at the University of Florida, with a PhD in agricultural economics from Purdue University, and joined the faculty at the University of Florida's Food and Resource Economics Department in 1987. And he has conducted research on a wide range of issues related to agricultural transformation, starting from agricultural finance to various aspects of agricultural productivity, for example. And Chuck has earned several prestigious awards, for example, the Quality of Research Discovery Award and the Quality of Communication Award of the American Agricultural Economics Association. So Chuck, we are very happy that you are here today, and you will talk about rural economic transformation in the Senegal River Delta. The floor is yours.
Okay, thank you. Let's get the screen up. The idea is I have 2 slide decks on this. I wanted to do one that was a little faster, so if you want to see the exact tables, I don't know if anybody wants to see the tables, I can pull them up. So we're starting with, and Carl said, can you say a little more about agricultural transformation? And so the basic concept of agricultural transformation is that as the economy grew, that there would be an emergence in commercial agriculture to help feed the labor force. Now, that's associated with an idea of farm specialization in developing countries. I'm a little bit off that topic. More and more, we have been working on supply chains. And the current supply chain that in this paper is on basically the rice industry in the Senegal River Delta area. A basic problem with small farmers, particularly in Africa, is that in addition to working with supply chains, you have a household subsistence questions and a great emergence of risk questions. I will point to this article. It just finally got real page numbers. That article is actually more on Rwanda, which I'll talk about tomorrow. But a basic question that gets into this analysis, and it's important today, is the choice of commercialization or the choice of market participation. So, overview is Senegal. Senegal's rural population, rural households, you throw the numbers up. We have a host or a sequence of what the first author, the graduate student, calls PCE, I call PSE, Plan Senegal Emergence. So some programs developed at increasing agricultural production and agricultural income in the Senegal River area. Now, the idea behind this paper was we had done a lot of work with the choice of crops, and we found out with the introduction of this plan, there were significant changes in the crop selection. And in the other papers, we talk a lot about the plan that maybe not as large of a shift in rice, which is the primary commodity, but a shift towards vegetable productions, particularly onions. So the idea at first was, well, we've done all this backup work. It'd be easy to do a difference in difference approach and show that there is an improvement in farm income associated with that. As we'll see, that really didn't work out to be as straightforward as we'd hoped. So we shifted to the welfare impact using an endogenous choice model. So this was actually mostly the Dong So's Bailey work. I actually allowed him to use data, which, as most people would know, for me is unusual. I usually require the students to write their own estimators. But we took a kind of a straightforward approach on this project. This is an overview of the actual study area. Now you see most of the data points, the red and the blue, the treatment villages being the blue, they're kind of paired throughout the sample. We have had some questions about the 4 villages that are kind of off the river valley, but we think that they are good control cases. So the data we started with was there was a household survey 2004, 2017, including 200 households and 200 treatment, 200 control groups. Now, as usual, when we start to work with this data, I'm always amazed, particularly more tomorrow in the Rwanda case. I always find a household that makes like twice my income. And so the idea is that there's always going to be either a winterizing or a treatment effect. So we've reduced the number of households using an interquartile range framework to try to focus on the issue at hand. So like I said, we basically start out with the simple difference in formulation. So we have beta 1 being the treatment, beta 2 being the time period, and beta 3 is usually where we see all the action. It's actually the effect of the program. But in addition to that, we want to introduce a different model, a selection model or a switching model. And in the switching model, we want to look at the difference between two groups of individuals. One is the participants, those that participate in more market sales, and one are the non-participants, so there'll be more the household or the subsistence variables. Then we'll compute the treatment effect using an ATT approach. So in the endogenous switching model, basically you're required to find a variable not related to the choice, but related to household. And we're going to use producer organizations, ownership of radios and ownership of TVs. We are looking at a falsification test, and if the variable is a valid instrument, it will directly influence the decision whether or not to participate in the market, but it will not affect the outcome variable for the household. In addition, to reduce the bias, we used a kernel matching with inverse probability weight. So basically, the big picture is we fit the difference in difference model, and the treatment was positive, the time period was positive, and the interaction between them was not statistically significant. So we couldn't find a classic DID impact of either the programs. So the idea was to switch to this model that highlighted market participation. So the amount of rice production produced, the membership, age, household, all have a significant impact on the choice that being a market participant. The market distance, then it have a negative impact. So what we have is that in the outcome, if after we control for the selection bias, market participation increased household income by 174,920 CFA, approximately $314.85. And it increased the dietary diversity score. At a policy decision, then it appears that a lot of the investments that have been made, some of the primary investments to have a real bang for the buck in a plan like Plan Senegal Emergent, is to pay particular interest in those policy variables that enhance market participation, such as infrastructure and roads. So I will leave it there. If someone wants in the discussion to see the actual statistical numbers, like I said, I do have them on another slide.
Thank you so much, Chuck, for introducing this interesting example on agricultural transformation and the role of market integration. I would like to invite the attendees of this webinar, please ask your questions in the Q&A function, and also let Chuck know if you want to see any tables, figures, numbers. As he said, he will be happy to bring them up. Meanwhile, we would like to continue with our next speaker, and I would like to introduce Will Masters. I think Will is also here with us, and I hope he can also switch on his camera. I saw Will before, but I don't see Will right now. Maybe we can ask conference services what happened to Will Masters.
Just bringing him back up. I'm sorry.
I think Will needs to be promoted, so to speak. Will is here. Okay, so welcome, Will. Sorry for this little delay here. It's my great pleasure to introduce you, even though you don't really need any introduction, I believe, in this audience, but still for the purpose of my role as chair. So Will is a professor in the Friedman School of Nutrition and Science Policy of Tufts University, with a secondary appointment in the university's Department of Economics. And before joining Tufts, Will was a faculty member in Purdue University and quite another number of interesting places, the University of Zimbabwe, among others. And Will received his PhD from the Food Research Institute at Stanford University. And he has also received several prestigious awards, for example, the Bruce Gardner Memorial Prize for Applied Policy Analysis. Will is also an international fellow of the African Association of Agricultural Economists, recognizing the role of his research on that continent, and also a fellow of the Agricultural and Applied Economics Association. And Will has conducted research on a broad set of topics, all relevant to agricultural transformation, including the political economy of agricultural policies. But one of his major focus of research, which Will is also talking about today, is food and nutrition policy. And as we have seen by Carl's introduction, food and nutrition has really become an essential part, earlier not recognized, of the agricultural transformation. So Will's title is Agricultural Transformation, Nutrition, Transition, and Food Policy in Africa. Will, the screen is yours. We look forward to your presentation.
Thanks so much, Regina, and thank you to everybody for joining. So this has been a great project to work on and to collaborate with this amazing group. So I'm going to follow directly on Carl's opening points, both about the overall agricultural transformation and also about technology, innovation in the private sector, and follow directly on Chuck's comments about market access. In his deep dive into Senegal, I'm going to zoom out to the agricultural transformation and nutrition transition and health, and that will lead, I think, quite nicely, I hope, to Jock's presentation on climate change. So the work I'm going to be sharing is collaborative with a number of people. So you'll see the connections that we're drawing between food policy and the agricultural transformation on the one hand, and consumer demand and nutrition on the other. So the main message I want to make and to leave you with is that we have so much more and better data now, and that's giving us clear policy messages. So here's the classic caloric undernourishment, the Green Revolution story that Carl began with. And what I've drawn here is from a forthcoming handbook chapter for the Handbook of Agricultural Economics. Volume 6 will be coming out in 2022. And this is a chapter on nutrition transition that I've been working on with Amelia Finarette and Steve Block. And what you see here is each individual country from 1990 to 2017 in the FAO's caloric undernourishment measure, with the green diamonds showing Africa. And what you see is Africa having a normal structural transformation path away from caloric undernourishment, thanks to overall increases in food in total calorie terms, and these converging towards the norm. So the countries that had very low caloric levels converging towards the norm as they develop, thanks to the infrastructure that Chuck's paper just described, market access, as well as the technologies that Carl began with. But when we look at nutrition and health, we need to remember that this obesity epidemic that's bringing a truly extraordinary burden of cardiometabolic disease in lifelong diabetes, in hypertension, in cardiovascular disease, strokes, heart attacks, and so forth. And regions differ quite a lot. So Africa actually being on average similar to other countries, but a little lower at higher income levels. And then Middle East and North Africa is the outlier up here in the yellow, with high levels of obesity at each income level. But what I want to flag here is that Africa is unusual in having relatively high levels of micronutrient deficiencies at each income level. So that's a central theme of our handbook chapter, is why is that? Why do African countries have this above average for each income level? And they're tracking the development path, not converging dramatically. And the reason really comes down to diet diversity, comes down to the micronutrient rich other foods that we are increasingly having to focus on in order to go beyond just the old Green Revolution 1.0 to this new challenges of nutrition and health. So what's going on? Very familiar to, I think, all of us. Africa's Green Revolution just didn't happen in its earliest years of independence. You know, African countries becoming independent from European colonialists around 1960. The Africa line in light blue showing no yield trends when other countries, other regions began their Green Revolution, in this chart shown just in cereal grains. But the key insight here is that Africa's Green Revolution has been proceeding at a normal pace for 20 years. So beginning around the turn of the century, the normal process of varietal development, dissemination, diffusion, adoption, accompanied by fertilizer, accompanied by soil and water conservation, very low irrigation rates, of course, so the overall level of cereal grain yield is much lower, but the productivity gains are normal, similar in pace to the other regions of the world. And as I think we can take away from Carl's opening comments, you know, the idea that there's family farms as a organizing structure for agriculture all around the world, whether they're small or large. In Africa, just like everywhere else, it's family farming, and the few exceptions, sugar, tea, palm oil, you know, are because there's some processing that goes on. So food industries are highly concentrated due to scale economies, as are input suppliers. That's why Carl's points about excludability of innovation and the ability to capture the value created by new technologies and input supply, and the value created by packaging processing that improves food safety, can preserve and deliver nutrients year round at low cost and so forth. That's really crucial. And so we have the kind of thing that Chuck described in the Senegal case, and we'll talk about in Rwanda tomorrow, where market access is just really crucial for this development process. So what's the point about agriculture's uniqueness? Well, it's that rural populations tend to grow because of total world population growth, shown here on this left diagram. I'll show you Africa in a moment. For the world as a whole, you know, urbanization proceeded rapidly. The world became roughly 50% urban around 2008, more or less. We're roughly now at the world's peak rural population, and world rural population is roughly stable. So globally, the number of rural people per unit of rural land, that's not just cropland, but also all the pasture and forest, water resources and so forth, we're about stable. Africa, completely different story. The heart of the African story is its youth boom and its rapid overall population growth, where even though the blue line of urban population, you can see this very rapid inflection that we're in right now. Africa in percentage terms of each city, each town, growing faster than cities anywhere else in the world have ever grown, at rates of 6, 8, 10% a year. In secondary towns, big cities, growing very, very rapidly. But because it's still most people in the rural areas in the red, rural population growth will continue. And that means shrinking land area, cropland, pasture land, and forests, water resources per farm family continue shrinking through the foreseeable future, getting to 50% urban, 50% rural out here around 2040 perhaps, but the rural population continuing to grow and therefore land area shrinking per rural person for the foreseeable. So the stakes could not be higher in terms of whether those rural people will in fact have the productivity growth that they need to keep up with the shrinking land area per rural household. Just to get a sense of the magnitudes here, China's rural population stopped growing in the early 90s, subsequently declined. India's rural population stopped growing about now. Africa's rural population will keep growing. Of course, China, India, enormous diversity within those regions, Africa as well. Africa's, of course, cut up into multiple countries, but the about 57 countries, just like India is cut up into states and China into regions. But of course, these turn out to be roughly similar in total magnitude of population. So you can think of Africa's rural future as roughly similar to China's and India's rural past. So these differences arise within countries and within regions as well. So look at Ghana's relative success. This is the rural population growth of Africa in red in the total. And you see how that continues to be quite high through the foreseeable future. Ghana, of course, had its dramatic macroeconomic reforms, investments in agriculture, and a sharp improvements in its overall rural non-farm employment as well as urbanization, and that job opportunity allowed them to have lower fertility rates and this slowdown in the rural population growth. But even Ghana continues to have positive rural population growth above zero. It's only countries like you see over here, Thailand, China, that got below zero so that the remaining farmers could have more land per remaining farmer because their neighbors had left. So the bottom line point here is that Africa has distinctly greater reliance on agriculture for employment. And this is from an early paper under our consortium project with Robel Alemu, who was I believe the first master's student funded under this project, coming from Ethiopia, from the Agricultural Transformation Agency there. And with him, we were able to do this paper that describes Africa's uniqueness in this regard, focusing in this chart on how total employment in agriculture is substantially higher and has not shifted down over time between the early 90s and 2010. So higher rural employment as a share of all employment in Africa because of this rapid rural population growth, young people being in some sense trapped on the farm, because even though cities are growing faster than cities anywhere in the world, they're small relative to the total rural population growth and unable to employ all those young people. So Africa has this distinctive reliance on agriculture to employ young people, and that's agriculture described largely, broadly in terms of rural non-farm activity as well. So this translates to higher rates of child stunting, because stunting, as we have discovered, there are many rate limiting factors that limit child growth, starting in utero, proceeding to breastfeeding and exposure to disease, then diet diversity in early infancy. Those all contribute to this higher level of stunting. But notice this sharp decline in stunting at each income level. So at the beginning of the Feed the Future strategy and ongoing through past these data, what we see is quite rapid reductions in stunting thanks to the investments in maternal and child health the first 1,000 days and so forth. But Africa remains distinctly high in its stunting levels for their level of income because of the lower levels of maternal and child health investments and the worse diet diversity that contributes to the problem. So rapid structural adjustment, structural transformation is certainly possible. So this chart shows you the path of structural transformation in a picture that was classically sort of drawn by Peter Timmer, redrawn here for our handbook chapter, just to illustrate the contrasting stories of China, which began this data period, 1991, it's a sort of normal poor country in a sense, very rapid, extraordinarily rapid, of course. But Burundi, this terrible case of civil war and going backwards in terms of structural transformation. So implications, Africa's needs are different from those of other regions. And I think the Feed the Future research strategy and the Feed the Future program generally recognizes that and does address the problem with the right tools. So this idea that land area per farmer will keep shrinking means that it's not about mechanization, except in certain instances to break a bottleneck. Basically, it's about the classic green revolution ingredients of varietal change, plus inputs, soil and water management, pest control, and so forth, tied to market access and processing as we've discussed. That's in contrast to the rest of the world. So keeping attention on the way in which Africa is different. The rest of the world is rapidly mechanizing its agriculture because the remaining farmers can take over their neighbors' land because of their much larger populations in cities, and their very different demographic patterns. So we see the relationship between Africa and Asia and begin to understand how this Feed the Future agenda fits into the global agricultural policy landscape, and above all, this agenda for diversification of agriculture and diversification of the diet, here showing the percent of dietary energy from all foods other than starchy staples on the y-axis here, East Asia having this classic green revolution and then diversification. South Asia as well, first horizontal and then growing diagonally. The world average also first horizontal. These begin 1961. That's the classic just undernourishment first, and then the diagonal movement towards more diverse diets along the y-axis, more foods other than starchy staples. The United States just oscillating back and forth here in total calorie levels because we had a diet that's very, very heavy in animal source foods in particular, and Europe as well. So the basic idea is that these, newly data-rich environment that we are working in gives us some clear policy messages where Africa's distinctive needs come from its unique political history and unique demography, where it became independent only in 1960, where it had a relative neglect of agriculture because of abundant land and a very high disease burden until very late deployment of public health measures. And so it has this high rural population growth, looking like what China looked like 50 years ago, what India looked like 30 years ago. So declining land per rural person just drives impoverishment and less productivity rises. And farm productivity growth began late, but it's underway. This transformation towards resilience and health involves this process of diversification, and that is itself also underway and needs continued investment in these diverse value chains, in the market infrastructure. And Ash Venkat will talk about in the next session how we're beginning to measure that with new data on food prices. The attention to diet-related disease is really crucial because this public health burden of obesity leaves people vulnerable to infectious disease, as we've seen in the burden of COVID, as we see today in the burden of tuberculosis, many other infectious diseases that are to which people are much more vulnerable when they have cardiometabolic illness due to unbalanced diets. And there's lots of opportunity still just to make the starchy staples more stable, more available in healthy forms, and of course, make that investment in the diverse value chains that are needed. We understand now that even remote low-income farmers buy most of their food, and so that market access is really crucial, not just for productivity, as Chuck said, but also for diet quality. And we're beginning to see more precisely how to do these investments. So really appreciate the chance to sort of share this overview with you, and I hope it helps in the framing of the presentations to come.
Thank you so much, Will, also for presenting this very interesting figures, new data, and drawing clear policy implications. I still invite all our participants to ask questions in the Q&A. We will have time to actually look at them. So please do that. And now I would like to invite our next speaker. The last speaker in this session is Jock Anderson. Jock is an emeritus professor at the University of New England in Australia, where he also received his PhD and where he was the chair of agricultural economics and business management before he joined the World Bank in 1989, where he served as an agricultural economist and rural development policy advisor. And he is certainly known to all of you. He is an expert in research on risk and decision theory, wrote a classic textbook on the topic with John Dillon and Brian Hardiker, but has also worked on many other topics that are relevant for agricultural transformation, in particular the role of agricultural research and extension, innovation, and agricultural productivity. He was also very early in looking at the role of gender, just to mention this topic hasn't come up yet in our discussions, in the international development policy agenda. And Jock also received many prestigious awards and professional elections. I will mention just three. He's a distinguished fellow of the Australian Agricultural and Resource Economics Society, an elected fellow of the American Agricultural Economics Association, and an honorary life member of the International Association of Agricultural Economists. Jock, we are very happy that you are here today, and the title of your presentation is Agri-Food Policy Responses to Climate Change, Adaptation and Mitigation. The screen is yours.
Well, thank you, Regina, and good morning, or whatever part of the day it is for you. It's a great honor for me to have this opportunity to join the stage with my distinguished friends and this, I think, a very fascinating session. I'm overwhelmed by Will's presentation, actually, and feel that we should have kept going with him rather than switch to me. Anyway, today I'm going to hopefully advance this. I'm going to talk dirty. And early in my career studying soil science, I realized that one wasn't allowed to speak about soil as dirt. But as you'll see in my presentation, soil plays a big part in the future of agriculture and climate outcomes, but not as big a part as many people would like to say. But it naturally means that our disciplinary span in considering these topics has to range over such arcane subjects as chemistry, physics, and engineering, as well as the nitty-gritty of the economics involved in all these aspects. So today I'm going to draw on two papers that are on the Rutgers website. Neither one published, and this one on adaptation first has been completed for the biotech conference, and the one I'll get to on mitigation is just very fresh as of yesterday. But first to adaptation. It's certainly going to be a very important part of transformation going forward, and especially so in Africa, and as Will was alluding to, Africa has many special issues to be dealt with that other parts of the world have already grappled with, although I would say in China's case, not yet very successfully. There's a lot of talk about so-called climate smart agriculture. It was the term was coined by FAO in 2010, but it's been taken up vigorously by many other development agencies, such as the modest World Bank. A question that arises through our thoughts about it this morning is just how smart is it, and is it smart enough? And as you'll see, I have my doubts about some of the degree of smartness involved. Which is to say that we have a big challenge to face to do something that is even better. A lot of the literature is very complicated because of the lack of adequate disentangling of climate change issues from those related to just natural climate variability. And that's been a course of, I think, some slow progress in articulating policies and interventions that really go for the climate change part of the story, which is of increasing problematics for our future planners and farmers, and ultimately, of course, consumers. Excuse me. So we have a lot of emerging global warming, and I prefer to use the term global heating. There's a lot of hot air in Glasgow this week and next, and hopefully out of that hot air will emerge some novel new ideas for doing a better job. that needs to be done unless we're going to fry. So let me talk about some specific policy issues. Heat tolerance is, I think, a yet underattended aspect of crop improvement and even animal improvement. There's been very good progress with drought tolerance work, particularly supported by Gates and others in Africa with the drought tolerant maize situation. But research on better heat tolerance is even trickier than drought tolerance. And so it's going to take quite a while to make good progress on that. And this is going to be especially problematic also for developing livestock strains that are more tolerant of the inevitably increasing heat to which they'll be subjected. So the bottom line out of all this is that we really need a lot of good innovative agricultural research. As Carl mentioned, a lot of this can be done through public means, but increasingly the private sector will also have to play a vital role, and that really gets us into the adequacy of intellectual property protection around the developing world in particular. So there's many unsolved issues in the adaptation story. It's not just hot days, but we're also going to have much warmer nights and heavy rainfalls. And the heavy rainfalls have their own implications for how farmers conduct themselves and how much they invest in structures to reduce, say, soil erosion, for example, which is bound to increase under the more intensive rainfall regimes that will come in many parts of the world. I'll point you to the interesting work by Tom Hurtle on the human health issues that are also going to be faced by agricultural workers and even managers probably, as well as the livestock themselves in suffering the greater heat. There's a vast scope for better cultivar development as part of adaptation, and many species such as fruits and vegetables, there's been not particularly good progress in developing heat and drought tolerance in the varieties, as well as, of course, attending to the nutrient density dimensions that Will is rightly raising great attention to. So the world is going to be hotter and more variable probably, and we need to put a lot more effort into how to living with that better. So let me switch briefly to the issue of mitigation. It's often too forgotten, I think, that the Green Revolution, amongst its many positive things, some of which have been pointed to in today's session, one of its really big deals was to spare such vast areas of forest from the conversion to cropland that they would have faced without the improvements in yields associated with the Green Revolution. So some agricultural technology developments can be quite green in many senses. There's also surely an active R&D role in forestation efforts of various types. There's been vast efforts in reforesting degraded areas in China, for instance, and that's been very much fueled by positive R&D outcomes in varietal selection and propagation technologies. You're going to hear a lot about the importance of conservation agriculture as a mitigation measure. The bad news is that conservation agriculture is so profitable that people largely want to do it at any rate rather than the traditional methods of cultivation. So in a mitigation policy perspective, you don't actually get a lot of so-called additionality out of conservation agriculture, even though it's obviously one of the key change agricultural practices that we really have to do if we're going to mitigate successfully. Unfortunately, the problem about building up soil carbon stores is that it's in many cases not very effective, and in most cases certainly not very reliable. And so it's very bad economics to be putting huge investments directed towards temporary buildups in soil carbon that can't be sustained and keep the carbon out of the atmosphere. So agricultural mitigation is challenging in many ways. It's slow, and just think about how one has to wait for trees to grow to really pull out much carbon from the atmosphere. It's technically difficult in many dimensions, and one should focus particularly on the possibility of developing new feed additives to help ruminants reduce their enteric methane contributions to the world. Methane being so toxic in global warming terms that it's one of the big reductions that needs to be made early to make really good progress. A lot of this is politically difficult, and we're going to see a lot of grandstanding in Glasgow in the next 2 weeks. But when it comes to the real crunch of doing things that are actually useful over the next few years to meet any of the bold targets that are being put forward, it's going to be very difficult politically to introduce policies that are really effective. And much lateral thinking is required for. One of the most bold lateral thoughts I've heard of is the idea that Mongolia's greatly overstocked population of ruminants could be reduced if we fed half the national flock to the hungry North Koreans down the but that's not very politically feasible or easy to happen. And making any sort of serious inroads into reducing, for example, Mongolia's ruminant population is going to be very tricky indeed, especially given the difficulty of implementing the carbon taxes that have been proposed. So, as I also mentioned already, the soil carbons situation has been touted as the big way forward from early in the climate policy debate, but it's increasingly apparent that it's really just not going to be very worthwhile and effective as a mitigation measure in much modern agriculture. So let me close with just a couple of quick thoughts. Transformation involves getting people out of agriculture typically, and that's pretty good. That might help agriculture reduce its contributions to greenhouse emissions. We've mentioned already at several times this session the importance of productivity growth in developing new knowledge, but that really requires active investment, and too much of the developing world is still spending far too little on R&D investments. We can rely to some extent on the CGIAR, but it has its own problems these days in increasing its real expenditures towards needed agricultural development. Policy learning is the way to go for all of us, and that's why we're sitting here together. Let me close with the question, can agriculture do its share in the mitigation that's needed? And my short answer is, I'm very sorry to say, I don't think so. And I've tried to outline that in a little paper that I've just mentioned. Thank you, Madam Chair. Sorry if I went over time. Please forgive me. Bye.
Thank you so much, Jock, for reminding us of the biophysical underlying constraints to mitigation. I think a very interesting thought. And I have to admit, I have not been a very good chair of the session because I thought we have a lot of time for discussion, but unfortunately we don't. I think we have maybe 6 minutes left. Since I was assigned also the role to be a discussant, I had prepared some discussion of your presentations, but I think I will skip those now and be rather concentrate in these remaining minutes to answer the questions that our participants have asked. And there were 2 questions to Carl's presentation, so I will read them to you, and I would ask Carl for a rather quick answer so we can actually get through the questions. So Andrew Tomes has actually asked whether there's an effect of GM regulations on R&D for other forms of crop improvement, like classical selection, hybridization. And Xiang Liu has actually asked whether public or government innovation will crowd out private innovation, and whether there's actually a need for government subsidy to private sector innovation. Maybe, Carl, you can quickly share some thoughts on these 2 questions from our audience.
Sure. For the first question, the main impact, I think, of the GM regulations on other forms of breeding has been on the gene editing, new gene editing technologies. Most of those gene editing technologies, if they put in a new foreign gene into a plant or whatever, will be regulated as GMOs. And secondly, a lot of the countries in Europe and China and elsewhere right at the moment are regulating the breeding, the gene editing technology as a GMO. So it is having impact on that, not so much impact on the other technologies yet, although it's possible that some kinds of technologies will be restricted. In terms of crowding out, public sector crowding out private sector, the only place that I've really come across this has been in some cases in China, some work that we did. But most of the rest of the world, it's the public sector investments are so low that it seems quite unlikely that there's going to be much crowding out. And then cost and gain. Oh, can subsidies help? Well, subsidies for R&D of various kinds have been attempted in most developed countries. It's not clear that they really work very well. But there is some evidence from China, again, that subsidies have increased the amount of private sector research.
Okay, thanks so much, Carl. We move on to Jack's presentation. Lourdes Martinez Romero was actually asking, I mean, you talked about the market participation and the dietary diversity impact on that. Can you say something about the magnitude of these effects? Maybe just how large was the increase in market participation, and how do we actually assess these effects in terms of their magnitude? Maybe you can say a few words about that, Chuck.
Well, I typed and responded in the so we had about market participation about what 274,000 CFA was the household level. So you're getting a market effect or an income effect of what, a little over, say, a half, which is pretty big, but it's a selection issue too, because households that are selected into market probably had a little bit over the mean to start with. The dietary diversity score is one that I'm not as, I mean, what, so Dong said, let's put the dietary diversity score in, and my first answer was, well, what does it mean? So we have a mean of 6.262. So, we're dealing with not quite as big of impact on the dietary diversity score, but, that's one that I have a little harder kind of an idea about what did it mean in the first place. But we are seeing more diverse diet. We are seeing an increase in the household income of a rather significant component. But, I think we probably should put a little bit more effort into disentangling the expected gain from that gain that's specifically related to the treatment effect.
Yeah, thanks a lot, Chuck. We had another question from Lourdes to Will Masters, but Will already referred Lourdes to the session of Aishwarya Venkat, so I think we can follow up then. And then we have two final questions, I think, to Jock. One from Keith Fugli, who says, does the contemporary transformation outlined by Oehmke imply that traditional Green Revolution constraints are not considered the most binding constraints to successful economic and nutritional transformation in Africa? He goes on to say the presentation by Carl Prey, Will Marsters, and Jock Anderson put significant emphasis on the need to increase farm productivity through adaptive R&D. If in fact research and extension have earned exceptional returns, this would seem to imply that R&D spending has been too low, and that the need for traditional Green Revolution adapted for African needs is still a critical constraint to successful economic transformation. So R&D investments too little and too late would be a question for Jock. And there's another question for Jock from Victoria Storm. To Jock, soil sequestration is not the best long-term option. Is it also true for regeneration of peat soils? In Europe, it is a prominent topic. What do you think of it? Thank you in advance. So the final two questions to Jock. And then I think we have to conclude the session in view of the time. Jock, over to you.
Okay, thanks, Regina. And thanks to Keith for a question that I think he, better than any of us, knows the answer to. And his own work has been pointing very dramatically to the severe underinvestment in ag research and development. And he's also done really great work in pointing to the role of the private sector in this domain. So yeah, a lot more needs to be done, and thanks to Keith, we'll keep pointing in the right direction to get that done. On Victoria's question, I'd say, yeah, sure. The loss of peatlands has been really most disturbing and a major contribution to the atmosphere that we're unfortunately breathing. And I realize that in Europe, there is a lot of good possibility for building up soil carbon, and especially in peatlands that have been degraded. And surely that's the same in much of Indonesia, but in many parts of the vast arable landscapes of the world, including Latin America and Australia, it looks like soil carbon type farming is just not going to really do much through soil carbon sequestration to solve the problems that we're struggling with in Glasgow. Thank you. And sorry, our session is so short.
Yeah, it's really a pity that it's so short. I think we're already 3 minutes over time. We also started 3 minutes over time. So let me conclude here by thanking all the panelists. I think it was a great panel, throwing new light on the agricultural transformation. I think it was also a good starting session, and more in-depth discussions of the various topics that have been raised here are to come. So please join me all in thanking our panelists for a great session, and we look forward. Please stay on for the next session, and I hand over back to conference services for bringing up the next chair. Thanks a lot.
I'll just mention that the next sessions, you get a 10-minute break now, and the next session will start at 10.